Okay, so this next video, I'm not sure if there's any homework in this one, but it's going to get us kind of prepared for the next thing, and just to kind of show you again how math builds on itself. We're going to use our definitions here to basically figure out what's happening in this situation. So first of all, I'm going to make you think a little bit, so I'm going to pause in a moment. But can you sketch me an angle that's the least positive measure, right, that contains the point -3,4 on its terminal side? All right, and again, so let's make sure again we're in standard position, right? That's pretty much the standard operating procedure now, right? And can you do that? Can you sketch an angle, right, the least positive angle measure that contains the point -3,4 on its terminal side? So again, let me mimic what would have done in a class. Let you guys think about it a little bit, and then I'll chime in. Usually what I do is I start getting information from students, but okay. So sketch an angle, standard position, right? That's the least positive measure that contains the point -3,4 on its terminal side. Alright, so let's see what you guys are thinking. Hopefully you're thinking something like this. First of all, let's start drawing, right, my axes and put ourselves in standard position. So I know for a fact, right, that my initial side starts along the positive x-axis, right? And then what we're told, right, is that the terminal side contains the point -3,4. So if I put some grids to this, right, x is -3 and y is +4, so that means that that data point, -3,4, falls on the terminal side. So that means my terminal side must be along that ray that contains the point -3,4. So now the challenge is, because of our coterminal angle situation, there's actually a million angles, right, infinite number of angles that have that picture, right, that has this initial side here and this terminal side ray with -3/4 on it. So there's actually an infinite number of answers, but I asked you guys for the least positive measure. So the fact that we're positive means we're rotating counterclockwise, and since it's the smallest one you can ever come up with, that basically means the angle that we're drawing is this guy right there. How about I call that angle theta as well, since we have it. So there would be the picture, right, of an angle, right, of least positive measure that contains the point -3,4 on its terminal side. Now, are there more angles that do that? Yes. We take away the word least. As far as positive measures go, right, I start here, rotate again, and I have another one, right? Rotate again, and I have another one. You don't want to rotate positively, you can rotate negatively, right? We could have rotated this way and also had a negative answer to that, right? And maybe I would have said that, right? Sketch an angle of the smallest, right, or the least negative measure. So lots of ways we can approach that. But this is a huge skill that's coming up shortly in 1.3, 1.4, and all that other good stuff. Very, very important. Loaded in our definitions. Notice how much I use the idea. We're talking about positive measures, so that gets in rotation. We're talking about terminal sides, right? Indirectly, again, I didn't say it, but it should be understood that everything's in standard position. And then least positive measure and all that good stuff. So there's basically your picture. The next question is another important one. It asks us, how far is the point from the origin? So we're just basically interested in that point. As a matter of fact, I can even do another sketch, if you will. Right? Here's the origin. And 1, 2, 3, 1, 2, 3, 4. There's the data point. So I'm asking, how far is that point from that origin? Right? So again, you could do it on this picture. Right? There's the origin, there's the point. So what's the distance? Right? So I'm asking for what that distance is. And hopefully you guys remember the good old distance formula, right? The distance formula, right, is essentially x2 minus x1 squared, or excuse me, plus y2 minus y1 squared square root. That's essentially what we have going on here, right? Because we have to find that distance. And going back to some college algebra, that is how we found the distance between 2 points. So here's x1 and y1, here's x2 and y2. just throw them into the formula. So how far is negative 3, 4 from the point 0, 0? Well, it looks like it's negative 3 minus 0 squared plus 4 minus 0 squared, the square root of that. That becomes negative 3 squared plus 4 squared, square root of that, which is 9 plus 16, and so we get the square root of 25. So what's this distance from here to here? It's 5 units away. Okay, so pretty important skill building, maybe a little bit of review. I know, I'm pretty sure I put that in our review. If not, I'll go back and fix that. But hopefully a review element, distance between 2 points, and then an embedded element in terms of putting some ideas together. Again, I constantly told you guys that's what math is. Take some facts and build some new facts on it. In this case, we drew a sketch of an angle of least positive measure, right, with negative 3, 4 on the terminal side. And then we also found how far it is from the origin. All right, so that pretty much wraps up a lot of the homework. The next conversation we're going to we're going to bust out our calculators. It's all this degree, minute, second stuff. And then we'll pretty much wrap up section 1.1. So thank you for your time. Get on Canvas, ask your questions, do those problems that I kind of left as Canvas questions. Hopefully that'll promote some discussion and allow me to see how much you guys are understanding. All right, I'll see you guys in the next video.